In this video, we're going to take a look at margin of error and confidence intervals. So a margin of error is how far that we would estimate our data would fall around a mean or a proportion. So like a measure of center. And then we have a margin of error in statistics that helps us to cushion our data, and we feel more confident that our data falls within this range of values instead of saying it's exactly this one value that we were able to figure out from our sample. So let's just look at two quick examples of this. Let's say the proportion of orange candies in one sample of size 25 is 60%. This would result in a margin of error of 19%. So to put this idea together, we have our sample proportion, which is notated as p hat in statistics. So the sample proportion is the 60%. So I'm going to put that as a decimal, which is 0.60. They told us that the margin of error was 19%. So let's write that as 0.19. And the margin of error, we always want to add or subtract to our proportion or to our mean, depending on what we're given, to get our confidence interval. So let's say 0.60 plus or minus the 0.19 is going to give us our confidence interval. So 0.60 minus 0.19 is our lower limit of the confidence interval. So if we take 0.60 minus 0.19, we get 0.41. And then our upper limit is what we get when we just add 0.60 plus 0.19, and that gives us 0.79. So then that is our confidence interval, 0.41 to 0.79, and it's written in the form of an ordered pair, but that's not what it represents. It really represents 41% to 79% if we wanted to rewrite it as a percent. Sometimes they do, and sometimes they just leave it as a decimal. Either one is acceptable. And then to interpret this, we normally state a level of confidence, but we just don't have to get that specific just yet. So let's just state we are confident, but normally we would say like 95% or 90%. But for now, we're just going to state we are confident that the true percentage of orange candies is between these two values. So is between 41% and 79%. So if you think about it, you've taken one sample of size 25 and you got 60% of them were orange. It would be too strong of a statement to say that you feel like the parameter of this data or the exact amount is 60% based on this one sample. So confidence intervals allow us to have more of a cushion around that data point. So we said 60% is our sample proportion. It's a stronger statement to say, well, the true proportion is probably between these two values because it could be a little more or a little less than that 60% because we only took one sample. So let's look at another example. In a poll of 1,085 preschoolers, 564 say Elmo is their favorite Sesame Street character. The standard deviation was 0.5. So what we're going to do is we're going to say the sample proportion, which they did not directly tell us, but they told us enough information to find it, is 564 out of our poll. So 564 like Elmo out of 1,085, which gives us 0.52. And our margin of error, we're going to use the formula approximately 2 times S, which is our standard deviation, divided by the square root of N, which is our sample size. So let's write that out. So S is standard deviation of our sample, which is usually what we have because unless they give you the population standard deviation, you don't have that. And then N is sample size. So it's not how many said yes that Elmo is their favorite. It would be the number that you asked. So in this case, that's going to be the 1,085 that were polled, that were surveyed. And so let's put this together now. We have our margin of error is approximately 2. And then our standard deviation they told us was the 0.5. So S is 0.5. divided by the square root of our sample size, which is 1,085. So if you type all that in your calculator, you get approximately 0.03. And then our confidence interval is always to take the proportion or the mean and add or subtract our margin of error. So let's take 0.52 plus or minus the margin of error, which is 0.03. And so our lower limit is going to be 0.52 minus 0.03. And our upper limit we call 0.52 plus 0.03. So you have to subtract it and add the margin of error to get your confidence interval. So that will give us a final number of 0.49 to 0.55 for our confidence interval. And to interpret that, we're just going to say we are confident that the true, and we could say percent or proportion of preschoolers, whichever way you want to say it is acceptable. So we are confident, let's say that the true proportion of preschoolers, so you always restate what it is you're talking about, the context in other words, that prefer Elmo, we will say, is between, and if I say proportion, I need to leave it as a decimal, so don't mix the two up. But if you say percent, you need to write this as a percent. But I'm saying proportion this time just to show you another way you can write it out, because this would have also worked for that first example. So is between 0.49 and 0.55. So we are confident that the true proportion of preschoolers that prefer Elmo is between 0.49 and 0.55. And again, you can write those as percentages, or you can write that as a proportion. And it would be estimating that if we could ask all of the preschoolers in the population, that we feel confident that the true number that think Elmo is their favorite would fall between these two values, which again is a stronger way to state your data than just saying this one sample gave me this proportion. Okay, so that's it for now for margin of error and confidence intervals.